Hello guys, welcome back to my channel DP Design, and in this video I am going to show you how to apply the loads and how to apply the boundary conditions. Okay, so as you can see, this is the cantilever beam where I have to apply the load on this surface, and I'll just go for the meshing load first. So you can switch on the load. I have created already the instances is there, so no problem. Okay, now on in this surface I have to apply the load in downward direction, and this surface I have to fix. Okay, so what I have to do, you cannot directly, if you go to the load options, okay, I'll just tell you, this is the different one. I'll go to the cantilever and apply the load. Here I will apply the load and select the step 1 which has been already created. Now if I apply the concentrated force, so what it will do, it will generally apply on the nodes only. Okay, so on and not the surface. So what if I want to apply on the whole surface? So for that I have to create one reference point which is connected to these surfaces, and then I have to select the load on one point which is created, okay, which is a reference point. So for that we'll just go through step by step. First, select the tools, go to the reference point and select the point you want to take it as a reference. Let's say I want to select this point as a reference. Wherever you can put reference point, there is no such as a boundary that if you apply the reference point here then result will change. Okay, that is only with the tie condition but not with the multi-point constraint. Okay, so for that I have created the RP1, and with RP1 which is directly connected to the surface, so I have to connect that. So for that I have to give it to the constraints. Okay, so go to the constraint. There are multiple options uh, which will be explored by in the future in the Abaqus advanced series. So for now I will create the multi point control point. Okay, multi point control. So I'll select the MPC control point, which is this one, and select the region for secondary nodes. So this is the region I want to connect. So done, and as a beam it will treat. So as you can see, my surface has been created. Okay, and my RP1 has been created as a MPC multi-point constraint. Okay, so now how to apply the load now? If you want to apply the load, there are multiple, you can apply whatever load you want to apply, like moment is there, pressure is there. Okay, pipe pressure, body force, all the things are there. So for now I have to apply the concentrated force on the point load, which is a RP1 has been selected and done. Now CF1, CF2, CF3, what is that? CF1 means X direction, CF2 means Y direction, 3 means Z direction. Okay, so as you can see the component, it is in a Y direction. I have to give the load, so it will be a minus Y direction. Okay, the component is symmetric, so wherever in whatever direction I will give, it will perform. So I will give the 0, and in this direction I will give the 2000 Newton of force. Okay, now if you okay, then it will show the direction of force also. Okay, so direction force it will be the opposite to the Y direction. And now I want to fix this face. Okay, this face I want to fix. So what I have to do, I have to give the boundary condition, then go to the initial. Okay, do not fix the geometry in the step 1 because it will give the error. You have to fix the in the initial whatever fixed geometry you are giving, which will be in the initial only. Okay, so in the initial there will be a symmetrical displacement. Okay, so symmetry I will give Ancaster option is there. Ancaster means all the degree of freedoms are logged. Okay, so that I want to need. And in displacement, if you want to apply the degree of freedom particularly off, okay, so that you can select the displacement rotation option. So I don't want that. For now I want Ancaster. Select the surface and select the face and done, and then go to Ancaster. U1 means X, U2 means Y, U3 means Z, and UR1 means rotational X axis. Then Y rotational will be UR2. So that's how UR3 will be Z rotational. Okay, Ancaster means all will logged. Okay, now you can see all the things are logged. All the degree freedoms of this phase is logged. Now my simulation is ready, okay, to get solved. Okay, now my meshing is also has been created. So what you can do now, you can create the job from here and select the cantilever, whatever processor you are having, like you can apply how many processors you want to use. Let's say I have a 12 core processor, so I can use the 12 core at a one time if you have the tokens. Okay, so I will create the OK, and you can select the directory where you want to save the results. So not in the temp directory, I just want to select in desktop trash one. Then I will create one folder which is having name the results. Okay, so in the results I want to save. Okay, okay, now I can submit the results and wait for it. So you can submit now and it will run. Okay, and you can monitor your results in between, like that. Okay, it will ask the permission. Okay, it will run. Okay, so that's how you can submit the simulation. And yeah, so that's the process. Okay, that's it for the video. Thank you for supporting. Keep sharing, keep learning.